Hello everyone. What I intend to show you in this video is how to approach the following problem. A car that weighs 14,200 newtons is initially moving at a speed of 45 kilometers per hour when the brakes are applied and the car is then brought to a stop in 4.8 seconds. Find the magnitude of the force that stops the car, assuming that it is constant. So the first step to solving this a problem of this sort would be to draw a diagram. So I'm going to start off by drawing a car. And what you have to do first of all is list all your initial, your final conditions, and everything that you're given in order to solve the problem. So in this case, we're given, well, we're told that we start off with 45. The car is moving initially at 45 kilometers per hour, right? And we're also told that the weight of the vehicle is 14,200 newtons. We know that when the brakes are applied and the vehicle is brought to a complete stop, the final velocity is going to be 0 meters per second. By the way, afterwards we're going to convert the VI to meters per second in order to be able to solve the problem. Anyway, back to what I was saying. So we're given that the final velocity is going to be 0 because it's brought to a stop in 4.8 seconds. So where do we start at this point? Well, first of all, let's take a look at our kinematic equations, which we've learned, which we've seen in class, which are these. The first one, VF minus VI is equal to A delta T. Second one, VF squared minus VI squared is equal to 2A delta X. And the third one, the fourth one. The first three usually help you out the most. Anyways, back to the problem. So what I'm going to start off with is actually converting my initial velocity to meters per second. So I'm going to say that my VI, or you can say it's VO, because like original velocity, whatever. So it's 45 kilometers per hour. So in order to be able to actually solve this problem, we have to convert this to meters per second. Otherwise we can, well, yeah, it would make our lives a whole lot easier. Anyway, so we know that 1 kilometer is equal to 1,000 meters. And we know that 1 hour is 3,600 seconds. And this is going to give us 12.5 meters per second. Now, we know that our final velocity is 0 in the x. So what we can start off with is the following equation, which is VF minus VI, which we see right over here. VF minus VI is equal to A delta T. So we know that our final velocity is 0, and we know that our initial velocity is 12.5 meters per second. We can find our acceleration from this. So let's write it out. Here we have VF minus VI is equal to A delta T. So we know that the final velocity goes to 0. We know that we're left with initial velocity, and we're solving for time. I mean, not time, sorry, acceleration. So here it's going to be minus 12.5 meters per second is equal to A. And I'm just going to bring the T over so that I can solve for it. Solve for A. So T, we're told that the car stops completely in 4.8 seconds. So it's going to be minus 12.5 over 4.8, which is going to give us an acceleration of negative 2.60 meters per second squared. Now we know our acceleration, we can go back to the original information that we were given about the car. Now we're told that the car weighs 14,200 newtons. And if we look at the car, it's not floating, it's not levitating, and it's not a plane, it's not about to lift off. So we can say that the force, in this case, in the y, is equal to 0. Because it's not moving up or down. There's no acceleration so it's not moving up or down. So we'll say that, well, let's start off with a free body diagram. So we have in this case we have the normal force and the weight. And because it's not moving up or down, like it's not going underground, nor is it flying, we can say that the normal force is actually equal to the weight. So we'll say that normal minus weight is equal to 0. So the normal force is equal to the weight. All right. So we know that the normal force is equal to the weight. And what is the normal force equal to? Because they're both, like, the weight is equal to the normal force. Well, it's equal to MA is equal to W. And remember, here we're dealing with the y-axis, right? Because these are components in the y. Because we're like as mentioned earlier, like I wrote out earlier, Fy is equal to 0. So what is the acceleration in the y? In this case, we're dealing with a car on the planet Earth. So the acceleration is negative 9.81 meters per second. So we can say that the weight, which we were given, which is 14,200 newtons, is equal to the mass times negative 9.81. But in this case, just to make our lives easier, what I'm going to do is I'm going to just take the magnitude of the acceleration in order to get the mass. So the mass is actually going to be 14,200 newtons divided by 9.81 meters per second squared, which gives us a value of 1,447.50 kilograms. Now we know the mass of the car. What we can find out now is the force that brings it to a halt, brings it to a stop. So we can say that the force is equal to ma, right? And in this case, we know our mass, and now we solved for our acceleration earlier, which is minus 2.60 meters per second. But here they're asking for the magnitude of the force that brings it to a stop. So we're going to put these two absolute lines on next to to the left and to the right of the force. Remember, force is a vector, but in this case, we're just taking the magnitude of the vector, which just it doesn't give us a direction. It just tells us how much force is going to be needed to bring it to a stop. So in this case, the mass is 1,447 kilograms, sorry, 0.50 kilograms times 2.60 meters per second squared. And we end up getting a force, the magnitude of the force being 3,763.5 newtons. Okay. So then the second part of the question is they ask, what distance does the car move during this time? Well, it's actually really simple. We can just look at one of the kinematic formulas, and the one in particular that I'm going to be looking at is the Vf squared minus Vi squared is equal to 2a delta x. And the reason why I chose this is because we know that our final velocity is 0. So let's just write out the formula. Minus Vi squared is equal to 2a delta x. So we know that our final velocity goes to 0. We know that this is going to be minus 12.5. Remember from earlier we got it. We converted the 45 kilometers per hour to meters per second. It's squared is equal to 2 times minus 2.60 meters per second delta x. Sorry, I should have probably moved this. Anyway, so we're going to say that delta x is equal to minus 12.5 squared over 2 times minus 2.60. And we'll end up getting a distance, the distance that the car went through is actually 30.04 meters. Well, I'm just going to write 30.0 meters. All right, thank you for watching my video.